Hi all, in this video I am going to explain multiple choice questions in electric circuit theory. Problem number 1. Identify which of the following not a tree of the graph shown in figure. First, what is tree? Tree consists of all nodes but no closed path. 4 options are given. Option number 1, B, E, G, H. B, E, G, then H. So this is a tree. It consists of no closed path. Then option B, D, E, F, G. This is also a tree. Then option C, A, D, F, G. This is also a tree. Then A, C, G, F. G, F. Okay, here see, this is the closed path. Formation of closed path. This is not a tree. Option D is the correct answer. Next problem. A two-port network is shown in figure. The parameter H21 for this network can be given by. First of all, I am going to write the equation of H parameter in a simplified manner. First, draw the H symbol and then have to mark the current direction. How to write the equation? V1 I2, V1 I2 in the left hand side. In the right hand side, we are having I1 V2, I1 V2, here H11, H12, H21 and H22. First of all, loop number 1 considered here, apply mesh analysis and write the equation. So what is V1? V1 is R into I1 plus R into I1 plus I2. So V1 equal to RI1 plus RI1 2RI1 plus RI2. And next see the next loop. In the loop apply the Kirchhoff's voltage law or mesh analysis. So here what is the equation? V2, this is the current direction, V2 equal to I2 into R plus I1 plus I2 into R. V2 equal to what? R into I1 plus 2R into I2. Here how we get the value H21? Here V2 equal to 0. Put V2 equal to 0, then only we get the value H21. What is H21? I2 by I1. I am going to find out I2 by I1. Put V2 equal to 0. RI1 equal to minus 2RI2. What is I2 by I1? R minus R by 2R minus 1 by 2. So minus 1 by 2 option A is the correct answer. Third one, the value of R is required for maximum power transfer in the network shown in figure. What is maximum power transfer theorem? Maximum power transfer theorem states that when source resistance equal to load resistance, the power transfer is maximum. Here we know the load resistance RL. RL equal to R. I am going to find out the source resistance or internal resistance or Thevenin's resistance. For finding out source resistance, what I have to do? First of all, I am going to redraw the circuit. Given circuit is redrawn by deactivating voltage source and deactivating current source. Voltage source is deactivated by shorting it and current source is deactivating by open circuiting the terminal. Have to redraw this diagram again. So see in this diagram, short circuiting the current source, voltage source, open circuiting the current source, then you have to draw the resistance 5 ohm, 20 ohm, 4 ohm. See in the 5 ohm and 20 ohm both are connected in which combination? That is parallel combination. What is the equivalent resistance? 20 into 5 divided by 20 plus 5, that is equal to 4 ohm. And see the net 4 ohm and this 4 ohm both are connected in series. So what is R equivalent? R equivalent is equal to 8 ohm. R equivalent equal to R. R equivalent value equal to R. So R equal to, that is the load resistance. The load resistance equal to the answer 8. Next problem, a delta connected network with its wave equivalent, that is Y equivalent, not Y equivalent, is shown in figure. The resistance R1, R2, R3 are respectively. Here delta is given and star is given. So first the inside delta you have to draw the equivalent star connection first. And in the equivalent star connection you have to mentioning the resistance R1 and here R2 and R3. Then you have to find out these values. First of all R1. What is R1? Multiply the adjacent resistance. What are the adjacent resistance here? 5 into 30. And add all the three resistances together. 5 plus 30 plus 15. That is 150 divided by 50. That is 3 ohm. And next, in the similar manner, find out R2. R2 is multiply the adjacent resistance 5 into 15 divided by the same 50. 75 by 50, that is 1.5. Then R3. 30 into 15. R3 is 30 into 15. Summation, that is 50. 450 divided by 50, that value is 9 ohm. 3, 1.59 ohm is the correct answer. Option D is the correct answer. Next problem, in the circuit of figure, voltage V of t. So what is V of t? V of t for the inductive circuit, the voltage across the inductor. So what is V of t? L into di by dt. Here I don't know the value of current. So what is the current flowing here? That is e power at plus e power bt. This current is flowing in the circuit. So L into d of, in the branch, not circuit, L into d of e power at plus e power bt divided by dt. So what is the differentiation? A e power at plus b e power bt. So option D is the correct answer. Next problem, in the circuit of figure, the value of voltage source E. Okay, here see in the circuit, voltage source is connected. So I am going to take this circuit. I am going to apply the KVL here. The first is 0, directly put 0. Then positive to negative, that is voltage drop minus 1. Here positive to negative, voltage drop minus 1, minus E. Then again positive to negative, voltage drop minus 5. Here positive to negative, positive, here negative, so minus 10 equal to 0. So what is the value E? E is equal to minus 16. Next, given that L of f of t is s plus 2 divided by s square plus 1, L of g of t is s square plus 1 divided by s plus 3 into s plus 2. Here, I am going to find out the value h of s. So, h of t is the convolution of both the signals. So, how to find out h of s is convolution of f of s and g of s. F of s is directly given s plus 2 divided by s square plus 1 and g of s is s square plus 1 divided by s plus 3 into s plus 2. Now cancelling both, I'll get h of s is equal to 1 by s plus 3. Option B is the correct answer. Next problem, linear time invariant system has an impulse response e power 2t, t greater than 0. If the initial conditions are 0, then input is e power 3t. Output t greater than 0 is. What are the values given? Impulse response is given, input is given. So how to find out the output? Output is h of s into r of s. Impulse response into r of s. So here the time domain it is given r of t equal to e power 3t. First of all, I am going to find out the equation in frequency domain by applying the Laplace transformation. So what is the Laplace transformation? 1 by s minus 3. 1 by s minus 3. And h of t is given e power 2t. So what is the Laplace transformation? h of s is 1 by s minus 2. What is c of s? Multiplication of h of s and r of s. 1 by s minus 2, 1 by s minus 3. Have to put this value. After that, what I have to do? I am going to apply the partial fraction. 1 by s minus 2 into s minus 3 is equivalent to a by s minus 2 plus b by s minus 3. Now multiply both sides by s minus 2 into s minus 3. S minus 2 and s minus 3. Here both are cancelled, and in this left hand side I will get 1. Right hand side s minus 2 and s minus 2 get cancelled. I will get s minus 3, and b into s minus 3 and this s minus 3 get cancelled. I will get s minus 2. So first of all, put s is equal to 3. S is equal to 3 means this term cancel, and b is equal to b is equal to b into 3 minus 2 1. So b is equal to 1. And the next s is equal to 2. The second term will be cancelled. Here 2 minus 3 minus a equal to 1 and e is equal to minus 1. Now I have to substitute the c of s is equal to minus 1 by s minus 2. A is minus 1. So I have to put the value minus 1 by s minus 2 plus 1 by s minus 3. Then I have to find out the inverse Laplace transform of c of s. So what is the inverse Laplace transformation? That is minus e power 2t plus e power 3t. So e power 3t minus e power 2t, that is the correct answer for this problem. The voltage E0 is given in figure. Here see, this is E0. The same voltage is in the nodal point. Here I am going to apply the nodal analysis here. So in the nodal analysis, have to mark the direction of the current. All the currents are flowing away from the junction. So first of all, I am going to write the equation. So what equation? E0 minus 12. E0 minus 12. Here it is upward, negative to positive. Both are opposing with each other. So E0 minus 12. Apply nodal. E0 minus 12 divided by 4. Okay. And then E0 minus 0 divided by 4. This is second equation for this branch. And for this branch, E0 by 4. The same. E0 minus 0 by 4 equal to 0. Have to take E0 outside. E0 of 1 by 4 plus 1 by 4 plus 1 by 4 equal to 12 by 4. So E0 into 3 by 4 equal to 12 by 4. 3 and 12 are get cancelled. That is 4 and 4 cancel. Finally I get E0 equal to 4 volt. Option C is the correct answer. Next problem, if each branch of a delta circuit has impedance root 3 Z, then each branch of the equivalent Y circuit has impedance. Okay, so first of all, I am going to draw the delta network and put the value for each impedance. All the impedance are same. And inside, I am going to draw the star network. In the star network, I have marked this ZY. So here all the ZY are same because the delta impedance are same. How to find out? I am going to find out this ZY. So ZY is adjacent resistance. Adjacent resistance are root 3 into Z, root 3 into Z. So root 3 into root 3 Z square. And then add all the impedances. Z root 3 plus root 3 Z plus root 3 Z. So 3 Z into root 3. Okay, here root 3 into root 3 into Z square. Root 3 get cancelled, and here root 3 and 3 are get cancelled, we get root 3. So we what is the answer? Z by root 3, that is the correct answer. Next problem, the transfer function of the system is given by height of S is equal to 1 by S square into S minus 2, the impulse response of the system. Here I am going to find out the impulse response. Okay, how to find out the impulse response of the system? Multiplication in the frequency domain, convolution in the time domain. So convolution is in the time domain, multiplication in the frequency domain. H of S is divided into two parts, 1 by S square into 1 by S minus 2. And next I am going to take the inverse Laplace transformation of H of S. I will get H of t. Okay, t. So 1 by S square equal to what? T. And 1 by S minus 2 e power 2t. So this is the correct answer. Option t into e power 2t. Option B is the correct answer. Next, the admittance parameter of Y12 in the two-port network is shown in figure. Here, first I am going to write the y parameter. Y parameter, normally what is y? Y is equal to I by v. So, I1 equal to y11 into v1, y12 v2, I2 is y21 v1 and y22 v2. This is a very simple method to find out y12, which one is common between the point 1 and 2. Between this and this is for example 1 and 2. What is the common value? That is y12. How to write this? y12 is minus 1 by 20. So what is minus 1 by 20? Minus 0.05 more. That is the correct answer.